Good morning, everyone. Not good morning, sorry. Kind of upset, I guess. So my name is Murishika Katayama. I'm an associate professor of economics at Waseda University. And today I'm going to talk about how to estimate something we don't observe in the data. So by doing this, I'm hoping that you'll be kind of exposed to some interesting aspects of data analysis. And in particular, I will be talking about how to estimate overtime work of Japanese bureaucrats at the Kasumi Gaseki using mobile location data. So here's the overview of my lecture talk today. First, I will explain what is mobile location data. And I will talk about how we can utilize mobile location data. And then I will talk about how to estimate overtime work using this data. So first of all, mobile location data is the number of people in a particular location over time. The location is called mesh. And this picture is, I'm not sure whether I can zoom in, but okay. So this is a kind of the primary mesh that covers the entire Japan. And this mesh can be subdivided into small pieces. So in the smallest mesh, it's going to be 200 meter by 205 meter mesh. And we can get to know how many people are in each cell. Okay? And the number of people will be identified by the usage and location of mobile phones. And there are two ways to identify number of people in the mesh. Okay? One is to use the GPS, that's a global positioning system. So whenever you use an app that utilizes GPS, basically you are providing some information where you're at. Okay? So that's one way. The another way is to use the accessing information to the base station. What this means is that whenever you turn on your cell phone communicates with base station, which is antennas. Okay? This communication happens at the regular intervals. So that information is going to be used to identify which mesh you are in. Okay? So by doing this, we can collect the number of people in different meshes at the very, very high frequency. So every hour, we will know how many people are in each mesh. So this is a kind of new type of data. Traditionally, we will be working with kind of low frequency data. For example, GDP is going to be available at every quarter. Industrial production or unemployment rate is going to be available at every month. But this type of data set is available. This is kind of updating number of people every hour. Okay? By using this high frequency data, we can get the different insights that we didn't have before. Okay? And in addition to the number of people, we can get to know additional attributes, gender or like age groups or residency information. Those are city level residency information is going to be available. So for example, at Waseda University, we can know how many people are coming to open campus and how many of them are coming from Okinawa, for example, or how many of them are coming from Osaka or from Chiba or from Saitama or Tokyo. We can calculate how many people are coming from those areas. And as I will show you in a second, there are strong periodical patterns that we can observe in the data. And also there are some locational characteristics associated with different types of locations. For example, business district or like residential areas or industrial areas, different patterns we can observe. So this is a snapshot of mobile location data. On the horizontal axis, we take time, and the vertical axis measures the number of people in each mesh. The top left one is showing you how population in Otemachi changes in the one day. So in the morning, almost no one is there. And around 6, people start to come to Otemachi area, and you see that many people will come to their office around by 9 or so. They're going to stay there for a while, and they will start to go home around 5 p.m. And I think you can see that the slope in the morning is much, much steeper than the slope in the evening, right? So there are some sort of heterogeneity among workers who goes to home, depending on their situation. Top right panel is showing you population dynamics in Kabukicho area. That's a downtown district in Tokyo, in Shinjuku. And unlike Otemachi, you can see that sizable number of people are in this Kabukicho area, even after the midnight. So these are the people, chunk of people who are staying in Kabukicho area. And it bottoms at the 6 in the morning and starts to increase gradually. Unlike Otemachi, you see some sort of slow pace of people moving into this Kabukicho area, and it's going to peak at 7 p.m. and then starts to go down. Okay? The different patterns you can observe for the residential area. Actually, this is my home. I mean, this is where I grew up until my age of 22. So people stay there like during night, and around 6 or 7, people start to go to school or go to work. And then people come back to home, and eventually that's going to go back to the original level. Rural area will have a different patterns. Like it's kind of flat. And this is a part of the Saitama area that I used to kind of take my daughters there is a river there. And you can see some spikes like around 6 or 8. I guess these are sort of the number of tourists coming to this area using a train. And this is the data based on weekday information, weekday observation. And if we compare weekends, we will see some different patterns. So if you look at the Otemachi, it's almost no one is there. Kabukicho, I guess that's a kind of similar. It doesn't matter whether it's a kind of weekday or weekends. And something similar we can observe at the residential area as well. But even during the weekend, people will go out. So that's why we will have some drop in the population. But if you compare dark blue one and light blue one, you will see that there are some people staying in this area during the weekend. So I guess this is kind of interesting data that we can at least infer something is going on. And I want to kind of utilize this data set. And in many practices, this mobile location has been utilized for different purposes. For example, I guess many businesses start to use this mobile location data to analyze the inbound tourist behavior. So tourists will have a different SIM card, right? So that's why we can kind of easily identify who are the foreigners. And typical patterns that we can observe is that they're going to come to Haneda or Narita, staying in Tokyo, and then go to Osaka, go to Kyoto, and then coming back to Tokyo and so forth. And it seems like there are some different patterns emerges, kind of going to Nagoya for first time and touring around and so forth. There are some marketing applications as well. We can use this mobile location data to analyze what are the sort of potential customer base. Okay? How many people are male and how many people are female, and then what kind of age groups are in this particular area, and so forth. And this is also used for disaster prevention planning as well. So if we use this mobile location data, we can visualize how people kind of evacuate once disaster happens. Let's say earthquakes or like floodings. And by doing this, we can kind of have a nice plan to navigate those people who evacuate during the disasters. So those are kind of typical usage for businesses. And on the right-hand side, I'm listing a couple of things that is kind of more related to the academic research. So during the pandemic, the mobile location data was really, really helpful because we can get to know how effective those mobility restriction policies are. Okay? And that triggers many papers start to kind of analyze what was the effectiveness of those policies to contain the pandemic. The second bullet point, the central banks around the world want to know what is the current state of the economy, whether we are in the good state or bad state. Okay? You may wonder, we can take a look at the GDP, or we can take a look at the unemployment rate. Those are available at the lower frequency. And for example, GDP, we will get the number, and that number reflects 3 months ago economic activity. That's not the real time. So we want to know real-time state of the economy. And mobile location data is going to be quite helpful. For example, Bank of Japan people are using this mobile location data to infer what is the current state of the economy. For example, if we look at the number of people at the shopping malls, if you see more people at the shopping malls, maybe you can say that, well, maybe we are in the good state. We can look at those industry areas where the manufacturing is located. Maybe typically people use, those farms will use one shift, but sometimes if it's busy, then 2 shifts or 3 shifts. If you see more people working at the factories, you will see that, okay, production output from those factories is going to be higher. So in order to understand current state of the economy, this mobile location data is now utilized. And the last one is something related to my work. So I use this mobile location data to study overtime work in Kasumigaseki. And from now on, I want to talk about what we did in our study. Before going to my study, this is a sort of digression, but I think this is an important digression, so let me talk about this. Often, we kind of emphasize that the correlation does not mean causation. Correlation means that the two things are kind of moving together or moving in the opposite direction. But it doesn't mean that one causes the other. Okay? And when we look at the mobile location data, we see some changes in the area population. That is quite suggestive. Something might be going on. But this doesn't mean that something is really causing the changes in the population or how people move. Okay? Because the area population is heavily affected by other factors as well. As we saw, day of the week, time of the day, and some seasonality also affect the number of people in the particular area. And weather, like whether the raining or sunny, or the temperature is high or low, those kind of things are also affecting the number of people in a particular area. Okay? In the special events, let's say there's some baseball game or soccer game, that kind of things will heavily affect the area population as well. So in order to make some causal statement, something affects the other, we need some exogenous source of variation that will affect the area population. So that is kind of important. And I want to talk about the overtime work. The reason why I kind of interested in overtime work is that overtime work is everywhere in Japan. I guess maybe outside Japan as well. And long working hours can be quite harmful to workers. And it is kind of well known that they are associated with adverse outcomes. For example, low labor productivity or health status is going to be deteriorated. Maybe mental health is going to be bad, or physical health is going to be bad, and so forth. And also, in general, we will have a not so good work-life balance, and also the welfare is going to be lower. We know that long working hours are not a good thing, but we don't know much about the nature of the overtime work. One of the reasons why that is the case is that we don't have a good data set. Data availability is the biggest challenge to study overtime work. Why? I think if you are in Japan, you have heard of service zangyo, like those overtime work without pay. Those are sort of misreporting. Like even though you're working, it is not recorded as working, right? You work, but you don't get paid. And also, there are some strategic use of managerial titles. Once you become a manager, you don't need to get paid for the overtime, right? So some companies kind of strategically use the title of managers. I'm not sure that's common in Japan, but it seems to be kind of common in the United States. So you'll be given some title of manager so that companies do not need to pay overtime. And economists often utilizes the policy changes to make some causal statements. Minimum wages, that changes quite frequently, but the regulations related to overtime work is not changing much. So that's why we know that overtime work is there, but we don't have a good data set to study overtime work. To tackle this problem, we want to kind of utilize mobile location data. We will try to describe quantitatively the changes in overtime work using this mobile location data. And I will utilize the data on something called memorandum of questions. I will call it MOQs, that is submitted to the Cabinet of Japan. I guess you will start to kind of wonder, what are you talking about? Let me explain these things one by one. So the politicians at the national diet, I think the asking question is their job. And there are two ways to ask questions. One is to ask oral questions that happens at those committee meetings or those plenary sessions of the National Diet. And those are something that is typically reported on the media, like a TV program kind of broadcast, like some politicians asking questions to the prime minister and so forth. Those are the oral questions. The other way is to submit a written question. That's called MOQs. And the law says that the cabinet has to respond to MOQs within 1 week once it is submitted. Okay? And politicians submit MOQs, and the bureaucrats are responsible for preparing answers. Within 1 week, you need to prepare the answers. You may think that that might be a kind of easy job to do. But the answers are the official statement of the government, so it has to be approved at the cabinet meeting. In order for the answers to be approved, it has to be ready 2 business days in advance. So including cabinet meetings, 3 days are already gone. And also you need to kind of go through internal kind of approval process. You need to talk to the boss will talk about his boss and so forth. Those internal approval process takes time. So what's gonna happen is that once I will be assigned to prepare for MOQ, basically I have to do the overtime. I have to work overtime, okay? This is the kind of nature of the institutional structure that is happening in the Kasumi Gaseki. So I will use this MOQ as a sort of source of, as an exogenous shock to the Kasumi Gaseki. The reason why we need this is that there are many people in the Kasumi Gaseki area. And maybe there are some taxi drivers in the Kasumi Gaseki, and we don't care about whether he's working overtime or not. I want to know what's happening to the bureaucrats. So the nice thing about MOQs is that submission of MOQs only affect the bureaucrats. Okay? So if there are more questions are coming from politicians, you can expect that the people will do more overtime. And if there are less questions coming from the politicians, you will expect that the overtime is going to be less. So I will use kind of this exogenous shock to the bureaucrats to estimate what's going to be the dynamic changes in the overtime. So that's what I want to do. So this picture is showing you the number of MOQs submitted every day. So my sample starts from, I will kind of analyze this time period from 2014 to the end of 2021. And it might be a bit difficult to see, but each bar corresponds to the number of questions submitted every day. Sometimes there are more than 20 questions submitted, and there will be no questions submitted. And politicians can submit the questions whenever the diet session is going on. Okay? So I don't know, that looks like a kind of exogenous and random to me. And I will use this information to estimate over time. And here's the Kasumi Gaseki area. As you may know, those governmental offices are located in Kasumi Gaseki, and they are nicely contained in 4 meshes. So I will just look at the 4 mesh and to see how area population is changing. So this is a picture. So every year, we see the patterns of those population changes. On the horizontal axis, that is starting from 5 in the morning. That is, and it comes from 5 to basically this is 27. That's 4 in the morning in the next day. And you can see that the kind of similar pattern emerge. Oh, shoot. So people come to the office and start to work. And unlike Otemachi, people in Kasumi Gaseki seem to go outside this region to have lunch. That's why you see some dip here. And coming back to the office and start work until 5 and start to go home. And sizable chunk of people are staying in the office even after the midnight. Okay? But looking at this picture doesn't tell me whether they are doing overtime work because of those questions coming from politicians or not. Okay? So that's why we need this information to sort of isolate overtime coming from because of the politicians or not. And these numbers contain the taxi drivers, those people working at the convenience stores in Kasumi Gaseki and so forth. So that's why we need something that will only affect bureaucrats. So that is this. Okay? The way we estimate over time is going to be as follows. So this is a kind of hypothetical picture, but the time on the horizontal axis and the population on the vertical axis, that's the same as before. And as we saw, around 5 people start to go home, and you will see some decline in population, in the area population. But this black line is a population dynamics after MOQs are submitted. That's what we observe. That's the data. By looking at this, we cannot say anything about, well, we know that some people are working overtime. Okay? But we cannot tell whether these are bureaucrats or not. If we could have something like this gray line represents average population without MOQs. This is a kind of hypothetical path of population dynamics without having MOQs. So if we could construct this line, we can compare this gray line with black line by saying that, once we get the MOQs, there's some deviation from the average population dynamics, and we can say that that is due to MOQs submitted by politicians. Okay? So we will use some statistical technique to construct this gray line and try to compare the gray line with the black line. And by doing this, we want to kind of estimate what is the gap that is coming from MOQ submissions. So in order for this to work, there is an important assumption that I have to make. That is that the timing and number of MOQs submitted are exogenous to individual bureaucrats. And I will start to argue that this is a reasonable assumption to make. I'm not sure you are I guess you are not familiar with MOQs, but if you kind of go to the Shugin website or Sangin website, you can get to know what are the contents. The contents are publicly available. And those questions are serious ones, and sometimes the really stupid ones are submitted. So the submission of MOQs are completely depending on the politicians. Some politicians submitted 20 questions in one day. If I try to kind of understand his or her behavior literally, he just came up with 20 questions overnight and then light it up and then submit all of them together. That's kind of unlikely to happen. So politicians have some discretionary power to submit these MOQs. That is not controlled by bureaucrats. So this is exogenous to individual bureaucrats, meaning that the bureaucrats do not have control, do not have any control over the submission of MOQs. I don't want to talk about the role of oral questions, but the bureaucrats are already working at the really tight schedule. So they do not have any room to work in advance. So if that is the case, this is okay. And we can check whether there is an autocorrelation in the number of MOQs submitted or not, but we can safely say that this is kind of exogenous to the bureaucrats. If you believe that this is okay assumption to make, here is the result we can get. So this is the kind of estimated impact of MOQs on overtime. And I guess this picture is kind of difficult to see. I just wanted to kind of zoom in, but I cannot, I guess. Can I? Hold on a second. No, I guess I can. I cannot. Oh, shoot. Sorry. Maybe I can zoom in here. Okay, good. So let's take a look at 7 p.m. dynamics. On the horizontal axis, this is different from previous pictures in the sense that on the horizontal axis, that's a number of days after MOQs being submitted. So 0 means that that's when the MOQs are submitted. 1 means 1 day later. 2 is 2 days later, and so forth. So 7 p.m. population dynamics, and the horizontal axis is a percentage change in the area population. The positive means that more people are in that area, in the Kasumigaseki area, after the submission of MOQs. So what this tells us is that on the day of MOQ submission, there'll be no changes in overtime work. So that's this picture, the graph starting from 0. And 1 day later, overtime work actually drops. There's a minus 0.4% reduction in area population 1 day after MOQ submission. And later on, gradually, area population starts to increase. And 4 days later, 5 days later, up until 12 days later, overtime work is going to be increased. We think that this is kind of interesting because I'm not sure you remember this or not, but MOQs must be answered within 1 week. But what this picture is telling you is that even after the deadline, overtime work is increased. How do we interpret this? Well, anecdotal evidence basically tells me that once, let's say, I'm assigned to prepare for the answers to the MOQ, I will do the overtime on that day for sure. I have an interview with those bureaucrats, and then all of them kind of tells me that, okay, I have to do the overtime on that day because I don't have enough time to postpone. What's going to happen is that I have scheduled meetings with my colleagues and so forth, but I have to cancel them because my primary job right now is to prepare the answers to the MOQ. And my colleagues will start to see me that, okay, I'll be busy and I cannot be utilized. What my colleagues will do is that they will go home earlier. That's what we see on the first day, the 1 day after the MOQ submissions. They want to do this because they kind of know that they will be busy later on. And I will postpone many things. And accumulation of those delays is going to be materialized, let's say 4 days later, 5 days later, and so forth. And since I postpone so many things, those kind of accumulated things, I have to pay those costs. And that's why we see that significant and then persistent increases in the overtime, even after the 1 week deadline. So that's our interpretation. We can see that similar patterns happening to the other o'clock, but I guess I will skip. And we can check whether our results are kind of reasonable or not. Some of the questions can be anticipated. For example, when the diet starts, there is always a particular politician who will ask almost same questions at every diet. That can be kind of anticipated. If it's anticipated, people can the bureaucrats can react in advance. If that is the case, our estimated changes in overtime might be kind of misleading. So I want to check whether what we do is kind of reasonable thing or not. So we can check whether the area population at T minus K, let's say, yesterday's population, will react to today's submission of MOQ or not. 1 day later, yesterday, 2 days ago, and 3 days ago, those are the things that is kind of summarized here. So what this says is that basically we don't find such anticipation effect. So at least we can safely claim that what we get from this picture is a kind of reasonable representation of what's going on in terms of overtime work of Japanese government bureaucrat. So how much time do I have? Okay, thank you. Oh, 5 minutes, okay. Maybe, no, okay. So here's a summary of findings. So 1 day after MOQ submissions, overtime work decreases. That's a sort of a surprise to us. Because I was kind of expecting that the overtime kind of jumps up and then stay there forever. But actually, we tried to construct a model to explain why this is the case. But initially, you observe a drop in the overtime work, and then starts to shoot up. And later on, overtime increases and persists even beyond 1 week deadline. So if this happens, or the increases in overtime is kind of contained within 1 week, I guess that's going to be okay. But you have to kind of pay the cost even after 1 week, then that's a kind of negative spillover effect to my colleagues. It's okay for me to do the overtime because I'm responsible for preparing the work, but I'm causing troubles to my colleagues as well. So this result suggests that the MOQs submitted by politicians have a negative spillover effect to other colleagues that is going to contribute to the increases in overtime in the Kasumigaseki area. So if we can uncover something we do not directly observe, those are kind of happening inside the building. But using mobile location data, we can measure how many people are in that area. And using this exogenous shock to those bureaucrats, we can estimate what are the dynamic changes in the over time by looking at, by using these statistical techniques. So somebody told me that I had 5 minutes, but I guess this is going to be the last slide. Is that okay? Okay. So as you may know, data analysis becomes increasingly important across disciplines, economics for sure, and political science as well. And this is partly because computing powers are becoming really, really cheap. And also, new types of data sets, such as mobile location data, becomes available as well. Those new types of data set will give us a different insights. For example, in the old days, we don't have any information about every other movement of people. So traditional economic theory kind of tries to explain, okay, there are some industrial, so along the economic growth, people migrate from rural area to the, urban area. But those kind of things are kind of slow-moving processes. And we have that kind of economic theory, but we do not have economic theories that will explain those, hour by hour movement of people. This will give us a new challenge to explain humans' behavior. And those new data sets are really nice in the sense that those alternative data sets will complement traditional data sources, such as the GDP, unemployment, those kind of officially available data from the government. For example, if we talk about Waseda, I think Waseda has an agreement with Mizuho Bank. That's one of the largest commercial bank in Japan. We have anonymized transaction data of the old accounts. So people at Waseda start to use those information to understand what is the kind of the behavior of those account holders. Those kind of things is going to be available, and that will give us new insights. But having access to the great data set itself is not enough. Visualizing what's going on in the data doesn't tell us an interesting story. It's going to be just the surface, right? So in order to make in order to kind of tell an interesting story, your idea and also your creativity is going to be very, very important to uncover something that we don't see in the data. And I think at the university, this is a kind of great place to develop and cultivate your ideas and creativity, especially at the Waseda, especially at the School of Political Science and Economics. We have a kind of active researchers community, and then different discipline of people are kind of talking to each other. So I'm a macroeconomist, but I do something like this because I can talk to political scientists, and I can talk to my colleagues who are good at doing some surveys and so forth. So the university is a really great place to cultivate your ideas and creativity. So I think, I hope that you now think that our program is interesting and attractive. Hope that I will see you, I guess, next year at Waseda. Thank you so much.